wait for the beach ball. Okay, I think we're good. So today we're gonna do a design atelier. I don't know how to say that. If you're anyone an architecture person, this is like when you get together and like do a design, or like you have like you all get together and do a design thing. So we're gonna design a database together, and we're gonna use Lucid to do it. And this will be useful because on Tuesday of next week at midnight, you guys have a database design due. So you're going to have to do a database design. If we're going to look in assignments really quickly and click on homework one, note that there's some specifications in here. It has to be submitted as PNG or JPEG, and then it has to have like a certain number of entities, and the entities have to have certain things and so forth. So it's not, the grading isn't going to be super strict, but try to do something, you know, reasonable. I like picking a domain or an area that I'm interested in so that it can be kind of fun to think about how to model that properly. And that is due on Tuesday of next week, so the day after we get back from vacation. Okay, so today we're going to do a design of a database, and typically in the past I've done school, I've done a zoo for a couple of years now, and I thought this time, just because it's so hot and all I can think about is skiing, we're going to do a database model for a ski resort. Database model for a ski resort, and what we want to model are the business aspect of it. We want to think about like what's the business of ski resorts and what are the things that we need to keep track of in a database. And let's just do a design for it. So let's get right into it. What's a good entity to start with? Does anyone have any opinions? Yeah. Season. So let's add an entity called a season. And what would a season have associated with it? Okay, so when we're doing our design, we're going to assume there's going to be an ID. We're not going to show like the foreign keys. We're going to imply those by the relationships that we put up. So let's not do IDs, and let's think about attributes, other attributes. So, someone else. What's an attribute of a season? Yeah. What's that? Bike versus ski, so maybe summer, or what do we want to call that? Snow total. Yeah, that's getting a little too much into the weeds. Let's do the high level stuff first. Like, what's something about a season? When I think of season, when I'm thinking about Bridger Bowl season this year, what am I most concerned about? Weather, yeah, I think that's right. Start and end date. I'm concerned about the start date, right? End date doesn't matter because youth baseball eats up the end of my winter anyways. So start date, and maybe end date. And then maybe we're gonna have like an enumeration. Maybe we'll have a summer versus winter flag. But that's kind of hard to talk about in this. So let's just have these for now. We'll probably have more that come along later. Okay, so that's a season. Give me something else. Someone who hasn't commented yet. What's another entity that's associated with a ski resort? What's that? Personnel. Yeah, and personnel can get pretty complicated. I'm going to throw that on here, and I'm just going to call it like employee. But we'll get to that. This is going to get pretty complicated over here. Is there a relationship between an employee and a season? What is it? Yeah. But let's think about, remember, the three relationships, one-to-one, one-to-n, and n-to-n. So can a season have multiple employees? Can an employee be present for multiple seasons? So what is that? It's a many-to-many or end-to-end relationship between those two entities. And what does that typically imply? Some sort of joint entity. And so I'm going to just be lazy about it, and I'm going to call it season employee, or employee season? What do you think? Season employee, employee season. Employee season. We'll probably rename it because joint entities typically become like something else. Like that might be like a higher something. I don't know. We'll think about that more. So, okay, so we've got a many-to-many relationship between these two entities going through this joint entity. What does that mean the relationship between employee and employee season is? One employee has many employee seasons, and so we can drag here to here, and it's a little bit small. I'm sorry about that, but hopefully you have good eyes and you can see it. That's a one-to-many relationship between employee and season. And since this is an end-to-end relationship between these two things, between season and employee, that means we're going to have a one-to-many relationship here as well. And that looks pretty reasonable to me. That's what I would expect to see. Like, okay, we've got seasons, we've got employees. The employees can be there for multiple seasons. Season can have multiple employees. It feels like something like this. And this might be like called, you know, like a seasonal hire or something like that. We can figure out a better name later, okay? Now, I know for a fact this is gonna get complicated because employees are always complicated. So let's focus on other stuff at the resort for now. So what else does a resort have? Yeah. A mountain. Yeah. Maybe multiple mountains, but probably just one mountain. Let's get a little more detail oriented than that. Ski runs, for sure. What's that? Tickets. Let's talk about runs and stuff like that first, and then we'll get into tickets. Tickets is going to be complicated as well. Okay. So we're going to call this runs. And what do runs have associated with them? What's that? Lifts, but like what's more like something specifically about the run? What's that? Difficulty, like name. Runs typically have a name and difficulty. Anything else? What's that? Maintenance level. Yeah, there might, let's hold that. I think that's right. But let's hold that because we might want to model that a little bit differently. Now, is a run associated with a season? Not really. Maybe because you like add runs and then maybe some runs like go away. So maybe there's a relationship between the two, but I feel like at least for a first pass, I don't want to draw anything between runs and seasons or between seasons and employees quite yet. Question. Accessible or not, yeah. But then again, anytime you think about like a Boolean flag like that, you have to think about like, is that something that's going to be date driven? Because maybe then what we want is to have another entity that has a start and end date for it in a certain state rather than just a Boolean on the thing. Okay, so what else do we have at ski resorts? Someone already mentioned it. Yeah. Rentals. I was thinking lifts, ski lifts. So let's add that for now. Okay, and a lift's got a name, maybe a vendor who gave it to us or sold it to us. Maybe like number of chairs or number of chairs. It's like a 4 or an 8 or whatever. Okay. Is there a relationship between lifts and runs? So what's the relationship? Some runs are accessible by some lifts. I think that's true. But are some runs accessible by multiple lifts? Are some lifts able to go to multiple runs? That's definitely true. So it feels like there's another many-to-many relationship here. So let's call that, so we're going to do a joint entity, let's call that lift access. And so what's the relationship between lift and lift access? 1 to many. What's the relationship between lift access and runs? Many to one. Many to one. This is a joint entity that we're including joint entities to get rid of many to many relationships. And I think that can make some sense here. So, okay. Obviously, as I said last time, come on, give me the, nope, that's not what I want. We're not putting in the IDs and the foreign keys, right? Which side of a 1 to n relationship does the foreign key go on? Goes on the n side. So if one run has many lift accesses, that means that lift access has a foreign key back to runs. And similarly, it has a foreign key to lifts. And so you'll remember what I said is these joint entities often have properties associated with them. And one thing I can think of for this joint entity lift access is whether or not that access is open or not. So for example, in Big Sky, they'll often rope off a particular part of the mountain so you can't get from one lift to a certain run anymore because like there's rocks or they're doing some whatever it is. So I can imagine deleting these, but then having something like open, something like that. And this again is a little dangerous because whenever you have a flag like open, you need to start thinking about dates. Like, do you want it to be just open or not open, or do we need to have some notion of dates when it will be open and when it might be some other state, something like that, okay? So, all right, this looks reasonable to me. Can I drag this around? Hold on. Let's see if I can grab this guy. So on that side, cool. Lifts seem pretty interesting. Lifts seem like they're always, to me, like the scariest part of any ski resort, you know, is like, boy, I hope those guys are taking care of those lifts, right? So there's maintenance associated with a lift. So what would we model, how does maintenance work for ski lifts? What do they do? They've got some sort of schedule, right? And in addition to maintaining the lift, just like the engine and all that stuff, they've also got chairs. So to me, looking at this, I think we probably want some sort of chair entity. Maybe it has a number, typically number of chairs, right? So what's the relationship between lifts and chairs? Probably 1 to many, right? Hopefully. Unless it's a real bad chairlift. Come on, baby. One lift has many chairs. That sounds right to me. And a chair's got a number associated with it. It probably also has like a vendor ID or like some serial number associated with it. Let's call it serial number. Okay. When we do maintenance on a chairlift, what do we look at? Probably the chairs as well as like the lift itself, right? So let's do the following. Let's add an entity called a maintenance and what would be interesting information, what would be interesting scalar information about lift maintenance? This is going to model us maintaining a lift in some way. Yeah. What's that? Interval, but like this isn't recording what we should do. This is recording what we're doing. So you and I are lift ops at Big Sky, and we're like, all right, it's time to start working on Swifty. And we go to a laptop and say, okay, begin lift maintenance. So what's associated with that? Again, one of the first things, it's not popping into your head right now. If it's not, don't worry, but it should, is date. Like you and I are starting to work on the lift on a particular date, okay? So start and finish. And then this lift maintenance could include what? It certainly is associated with a lift. Certainly associated with a lift. Question. And there's probably a relationship with employees too. I think you're right. But let's think about it, the relationship with lifts and chairs. What's that? Yeah. So in one lift maintenance entry, do you think we can work on one lift or multiple lifts? What do you think? What does lift maintenance mean? And there's not necessarily a right answer here. There's not necessarily a right answer here because maybe in our system, a lift maintenance is just defined as like only one lift at a time can be worked on. That makes some sense to me. So what do you guys think? Yeah.
Each lift is probably going to break down.
Yeah, and we're going to do maintenance on one lift multiple times, obviously. So I think the question is this a one lift to many lift maintenances, or is it a many to many relationship where one lift maintenance can involve more than one lift? I think for simplicity's sake, we'll say that lift maintenance only applies to one lift. But that's just a decision that I'm making right now to keep my life easy, to make it a little bit easier on me, okay? So that means there is a one, come on. That means there is a one to many relationship here. One lift has many lift maintenances associated with it. But one lift maintenance is associated with one and only one lift. What about lift maintenance and chair? Yeah, I think the way I would expect this system to work, if I sit down on a laptop and I'm working with a guy and we're maintaining the lift, we're either working on the engine or we're checking the chairs, like running through and doing the x-rays or the chairs and the cable and all that stuff. But it feels to me like even though a lift maintenance is associated with one lift, it's associated with many chairs, okay? Now, a lift maintenance can be associated with many chairs. Can a chair be associated with many lift maintenances? Yeah, absolutely. So what does that mean we need to do here? Add another joint entity, right? So we're going to add another joint entity called chair maintenance. I don't know how to spell. Hope that's right. Size this a little bit. I feel like it should be smart enough to do that. And so what's the relationship here? Well, it's one to many from chair to chair maintenance, and it's one to many from lift maintenance to chair maintenance. And so how would this look in like an app that we're building? Well, we'd probably have a UI with a start and an end and maybe some notes about the lift itself. And then we would have a list of chairs and what was done to them. What was done to them, okay? And so let's put in here for field notes, it's common to have. And then let's, in chair maintenance, put notes as well. And this again shows how joint entities often start acquiring information. So even though this started as a joint entity, because we realize there's a many-to-many relationship between a lift maintenance and a chair, it starts to acquire its own data. So these joint entities tend to grow up and become useful, not just pure join entities. When we look at the Chinook DB schema, I will show you there's one pure join entity in the system, and remind me to point that out. But that's unusual. It's unusual. Okay. So it was pointed out that a lift maintenance probably also has an employee, some sort of association with employees. What's the relationship? Could a lift maintenance have multiple employees associated with it? Could an employee be associated with multiple lift maintenances? Are we seeing a pattern? One-to-many relationships come up again and again in business. Like, this is just the way that it is. And so these joint entities just keep popping up. And then again, what you're going to realize as you go through it is, oh, wait, there's information about that relationship that I want to capture as well. Okay? So what are we going to name the relationship between employee and lift maintenance? Yeah. Maintenance job, maybe. Let's call it job. And again, since this is a joint entity, we're going to go one-to-many and one-to-many. One-to-many between the end-to-end relationship. One employee can work on many lift maintenances. One lift maintenance can have multiple employees on it. What's an attribute that can go on this job? Completed? Maybe. Completed to me feels more like it might be down here, though. Start and end? We could add a start and end, and what would that be saying? We've got a start and end for lift maintenance. What would it mean to add start and end to this job? When the employee is working on the job might be different than the length of the job. So for example, your lead lift ops guy might come in at the start, make sure everything's good, and be like, okay, here's what needs to get done, and then he peels off to another job. Right? Or she peels off to another job. Number of employees, that's an interesting question. So let's add start and end here. Can I do it here? Okay. So the comment was made, well, what about like what about a count of employees? Where would we put that count? If we wanted a count of like the number of employees working on a particular lift, yeah. It'd go right here, wouldn't it? So we'd add another field. We'd have like employee count. But what did we talk about last Wednesday, this past Wednesday? What did we talk about? Someone has to say the word. Redundancy or normalization. Employee count, if it's 5, is that information anywhere else in the database? This is really hard to see at this point for you. Yes. Yeah, that's true. That's the insight right there. Is the employee count is redundant with the number of job entries that map to this lift maintenance. So if there are 5 employees working on a job, then there are going to be 5 entries in this job table that have that foreign key, have a foreign key to that lift maintenance. Okay? So there's redundant data. And what's the danger? What's the danger there whenever we have redundant data? We have the same data in two places. And so what if the number in employee count is 3, but the job table has 5 entries in it for a given lift maintenance? What does that mean? What does that mean? And so that's an example of a violation of database normalization. Because we have a value in our table that does not depend only on the primary key. It depends on other data. Depends on other data. So this is not in third normal form. Now, I said last week, you might still want to do this. You might want to go to the trouble of keeping a column like this updated. And why did I say you might do that? What's that? Louder.
Speed.
Performance. Because if you have this number here, then you don't have to join over, and we'll talk about what joining is in 2 weeks, I think. You don't have to join over to the jobs table and then do a count. That takes time. That's not free. Now, most databases are very fast at it, so there would have to be a very good reason in my mind to not do that. But that's a reason why if showing the number of employees on a job was super important for your online system or whatever, and you had determined that it was very slow to do that, then you might denormalize in the name of performance. Okay? So let's for now delete that, because I think we would derive that instead probably from a query, and that will be what's called an aggregation query or group by, if you've ever seen SQL before. That's what we would use to figure out that count. Okay. All right. This looks pretty good to me. I'm pretty happy with this part. Let's talk about employees. So we've got a season. Actually, you know what? What do we not have? What are we not modeling? That's the most important thing to me. Tickets. Customers. We got to have customers. Tickets. Unfortunately expensive tickets. So let's give ourselves a little bit of space over here, because I feel like tickets are going to be associated with a season, at least if you're lucky. Okay. So how do we want to model this? What do we want to start with? Well, let's start with a ticket, like one ticket. One ticket to Bridger Bowl. Ski ticket. What are some attributes of a ski ticket? Name. Does the ski ticket have a name? The customer. Customer has a name. So we're going to have a customer. That customer is going to have a name. And then what's the relationship between ski tickets and customers? Can a customer have more than one ski ticket? I hope so. I like skiing more than once. Can a ski ticket have more than one customer? Shouldn't. I don't think you're allowed to do that, but I know some people do. Let's not model that. So let's say one customer has many tickets. Cool. So customer has maybe a first name, last name, and really importantly, a credit card. Cool. What's the relationship between a ski ticket and a season? Is there one? Yeah, ski tickets. Let's give it a code. You know, they've got codes on them. So let's just say there's a code on there, just to put something on there. But would we model the relationship between a ski ticket and a season as just maybe putting like an end date on the ski ticket, or would we put a foreign key? So I'll give you the answer. One season can have multiple tickets, but one ticket cannot have multiple seasons. So I can think of two ways to model that. One is to put an end date on like when this ski ticket is valid. And another is to put a foreign key between the ski ticket and the season, and then derive its validity end date by the value that is on the end date here. Those are two reasonable approaches. What are the benefits of putting the date, end date here? What's an advantage of that? You don't have to go over to the season table to find out when a ticket is no longer valid. What's another advantage of it? Yeah, so there's, you guys have probably seen this, like you can buy a ticket and it's valid for like 2 weeks. So it's not valid until the end of the season, it's valid for 2 weeks, right? Yeah. Buy a ticket without a season time established, like before the season has an end date maybe, or something like that, true? So if we want to support the feature of ski tickets having multiple days associated with them, then yeah, maybe number of days, something like that. I'm using camel case here. In a real database schema, you probably use snake case, which is underscores between words. I don't know why I've got camel case on my brain right now. If we have number of days on here, what do we probably also want? What does number of days imply? A use count. So do we want to throw a use count on here? How else could we model that? We could subtract from the number of days, but if we do that, then we can't go back and see how many days it was for originally. So I like keeping the number of days it was for around. But just having a number of uses on here seems a little wrong to me. The way I would probably model this is by adding another entity. Ski ticket usage. And that probably has a date. Not a start and end, but a date. Then what's the relationship between ski ticket and ski ticket usage? Make it bigger. Just want to make it bigger. One ski ticket, many usages. That's what I think of. Does that sound right to everybody? So ski ticket, we've already just said maybe associated with a season, but maybe not. Maybe we'll have an end date in here, so it's a little more flexible. What about ski ticket usage? That feels to me ripe for being associated with a season. Because while a ski ticket is kind of independent, maybe like you let them roll over, I don't know. I don't know if it's totally associated with a season or not. Someone using the ski ticket, to me, feels like that's definitely associated with a season. Okay? So one season can definitely have many, Bridger Bowl certainly hopes so, many ski ticket usages. Can one ski ticket usage have many seasons? That doesn't feel right to me. So I think this is a one to many. Hold on. Come on, baby. I think this is a one-to-many relationship right here. And now, congratulations, we've hooked everything up in our ER diagram. So what can we find out? Well, we can find out something like, for a given customer, in a given ski ticket usage, in a particular season, what employees worked on a lift on days when that person was skiing? That is a question you could answer with this schema. You would need to know SQL. You'd need to know SQL to do it, but that's a question we could now answer with this schema. Why might that be important? Maybe you need to get all the skiers who were on the mountain on a day when something bad happened and offer them a free ticket to not sue you or something like that. Right? But we've got total connectivity between our ER diagram, and this is how it typically is. There's almost always total connectivity here. So let's try and model one more thing, and then we'll call it a day. What about season tickets? How do we model season tickets? Are they a ski ticket? Yeah? Season pass, yeah. Are they a ski ticket? Like, do I mark like number of days infinity? Could, maybe, I don't know. I feel like they're kind of a different thing. And why do I feel like they're kind of a different thing? I feel like they're kind of a different thing because to me, a season pass has a relationship with a season that a ski ticket doesn't quite have such a strong relationship with it. So I'm going to add another thing called season pass. And to me, a season pass is associated with one season, but a season has many season passes associated with it. Okay? What about ski ticket usage? Would a season pass be related to a ski ticket usage? I see one person shaking their head and one person nodding. I like it. Because the answer is depends on how we decide to model it. So we could add a season pass usage that models a, what would that be? A many-to-many relationship between season and season pass. One season pass could be used multiple times in a season. One season would have multiple usages of season passes in it. So that's a many-to-many relationship. So we could create a join table here. I don't even know if we talked about this ski ticket usage as a join table, but it is. Because it's got two many-to-many relationships coming in. So we could add another table, another many-to-many relationship. What else could we do? We could reuse this table for that relationship. We could bring in two one-to-many relationships. Question?
In the ski ticket usage table,
Yeah.
there's days, but you could also theoretically check whether that date, and it's connected to season, but you could check whether that date starts and end of the season.
Yep. That's a good question. So we've got a date here, and we could look at these two columns and determine whether or not a usage was within a season. So there's a little bit of redundant data here, and there's a possibility of some incorrectness, right? We could have a season with a start date and end date, and then a ski ticket usage outside of that range. We could certainly do it that way, but in most real-world systems, we would not. And in most real-world systems, we would not because of performance. Foreign keys, integer lookups, as we'll see when we get into it, are much faster than range lookups. And so in any real world system, you're almost always going to have a foreign key. But I think that's one of the levels of normalization that this schema isn't satisfying, like fourth or fifth normal form. Because we do have data implicitly encoded in two different places. Okay? So what I did is I drew a one-to-many relationship between season pass and ski ticket usage. Right? So we now have a one-to-many from ski ticket, a one-to-many from season pass, and a one-to-many from season. So this table has a foreign key back to season pass, and back to ski ticket. So what does that mean about a row in ski ticket usage? You need to know whether or not a given row in this table refers to a season pass or to a ski ticket. So one of those columns should be null. One of those columns should be null. The foreign key back to season pass should be null if it was a ski ticket usage. The foreign key back to ski ticket should be null if it was a season pass usage. So what do you guys think of this pattern? Would you prefer to create a season pass usage table? What do you think? I see people shaking their head and I see people nodding their head. And the answer is there's not a right answer here. The advantage of this approach is particularly if we do what we should, which is one customer can have many season passes, is that you can join through season pass and ski ticket usage and through ski ticket and ski ticket usage to get out to information like, was this person on the mountain when a particular lift maintenance was occurring? Okay? So there are advantages to putting everything through this table, this single table. But there's also disadvantages. It's a little confusing, and you could have bad data. You could have a row in ski ticket usage that has a foreign key to season pass and to ski ticket, unless you're careful, unless you put constraints on your database that say that particular configuration of data isn't allowed. Question?
With this format, does it make it easier for calculating sales numbers?
Definitely makes it a lot easier to figure out how many people were on the hill on a given day. For sure. So we got a date here, we can just count it. If we have two tables, then we got to count them and sum the thing, and that's not something you typically do in SQL, and it can be hard to correlate the two. Okay. So yeah, that's just a decision that you've got to make when you're designing your database, like what's important, what's not important to you. Okay. All right. We've been grinding on this for 43 minutes now. I don't know, what do you think? Does this seem got kind of complicated? Does this seem complicated to people? Like a little bit?
Something I want to figure about is how do you come up with the naming schemes for the join tables? Are you just choosing an attribute that
The default way that I will name a join table, if there's no obvious name for it, is one entity, other entity. So if I'm joining employees and cars, it's employee car or car employee. That's a bad name. So then I think about it for a second and say, what is that really? That's like a car usage. And then I'll turn it into car usage. And then I'll start thinking about what are the attributes associated with a car usage? Okay, like when did it start? When did it end? That's a very common thing to put on join entities, like data about time, temporal data, very common to put on join entities. But then, there's more stuff, like was there an accident? Well, an accident isn't associated with a car or an employee, it's associated with a car usage. So that's going to join into that table, how that relationship, hopefully not multiple accidents per car usage, but maybe you have to model that, right? It can get complicated. So we spent, now 45 minutes building out a schema for a ski resort. I would say this is probably 1/100th of a real world schema. Maybe not 1/100th, maybe 1/50th. But like in real world systems, there's a lot more. They're massive. So SAP is a famous ERP, what is that, revenue management system? I forget what it's called. SAP, very common in large businesses, and their database schema has 10,000 tables in it. So it can take you years to learn even part of that schema. Okay? So we did our thinking, and I think this is a good exercise to see how databases are designed. The database we're going to work with isn't much more complicated than this. It's got a few more things going on that I'll point out, but this is very, very small, despite how complicated it got. You see how it just spiraled? Like whenever you drill in on a concept, it just spirals. Suddenly you're like 10 tables in and you realize, oh, now I got to join these, and just keeps going. And that's the way these things are. So when you go out into the real world and you ask for that schema diagram and they give it to you and it's massive, don't freak out. Focus on the parts that are important to you and just learn that part and then grow out from there. Grow out from there, because real world systems are very, very complicated. Okay? Okay, that's it for now. Enjoy Monday off. Homework is due on Tuesday. It's going to be an image submitted in Canvas. So good luck. Hey.
I was curious if there were any more guidelines